So, good afternoon. Thank you very much for coming to this talk. I'm kind of surprised at the amount of people are here. You sit there and you've got almost the last talk of the day, and you kind of sit there and wonder, am I going to be presenting to 2 people at the front or a slightly larger audience? So today I'm going to talk about Splunk and how it's used in the IoT space, kind of log I am your father. I've done my best with the title, and the interesting thing about this is, who here thought they were going to be a policeman, an astronaut, a fireman, or something like that when you were about that small? Now, I certainly did. And now I sit there and I look at log files and data streams, all that type of stuff. I've actually got to the point I even have my favorite log file and my log type. So as you go through this, think about that yourself. And the really interesting part about it is there's lots of value and insights you can get from this seemingly kind of horrible piece of data. So firstly, Splunk. In the States, it's fairly well known. So when I go through customs, and you say, who do you work for? Splunk. They, oh yeah, from Splunking. And so really, it comes from the term to go exploring underground into caves. When we originally founded, just over a decade ago, they were sat there thinking, I've got all of this data, and it just feels like I'm having to mine through it. And they felt it's quite an appropriate name for it. If we were maybe based in the UK when we got started, we might have been called something like Pothole as a company. So I'm kind of not sure which worse, Pothole or Splunking. And the whole point about this is exploring machine data. And now what we're really talking about is exploring your IoT data. It's machines have all been around for a long time, but the concept of being able to take data off those devices and be able to use that to gain some insight and some value is relatively new. I'm sure that some of you here have probably played with Arduinos or Raspberry Pis and things like that, going up to huge industrial systems. And there's kind of the data that we know and we use very regularly. When I started off at university, I spent most of my time learning about kind of BI structured data, things like that. And there's a huge amount of data that wasn't originally touched. So many projects we hear about where they didn't actually think about that data could be used for anything other than its original purpose when they started. And it certainly is like this in a pure BI world, nicely neat, structured, but we really started with log files. And in those log files, you've got data flowing, time series, in motion. It's kind of unstructured it's a loose term. It's at least semi-structured. Anything generated by machine is probably generating it from a template. Therefore, at least it has repeatable patterns in that unstructured data. And may also be JSON, XML, all of those type of things. And it's fairly intertwined and quite hard to untangle and realize what is actually going on there. And I couldn't help myself with this slide. You've probably never seen this one before. It, of course, can be big data. But the most important thing about it is big data for me is we've almost shot ourselves in the foot as an industry. So I go and speak to people and say, but we're not using big data. We're a medium-sized enterprise. We're not generating more than a gigabyte or so of data per day out of our industrial devices. So, well, that's fine. The whole point behind big data is being able to take that stream of data, transform it, and use it for something, rather than having to go through a huge BI project to be able to work that out. And that's really kind of what big data means for me. And there's kind of slightly crazy data, especially when you get to IoT, trying to be able to understand it. And it's certainly messy and very lazy. It doesn't really do much for you. You have to work at understanding it, enriching it to be able to get some value out of it. But it has many uses. And this is where it comes back to my favorite log file. So my favorite log file is, and this is kind of like a confession here, is an HTTP access log. And the reason why I really like it is it's very prevalent. Most people have seen it or can understand the concept behind it, but it tells me that something happened. And we all know a 404 error or 200 is okay. So straight away I know something happened. Did it work? Did it not work? I also know where has something come from, maybe the client IP address. So enriching that, I might be able to put a security context to that. I may also want to then link that into a customer ID, maybe based on a session or something in that URL, and be able to enrich that with CRM data to say, my important customer, or was it an important customer, and did that web page actually work for them? So straight away, a very crude example of customer experience. Then I can start to look through, am I compliant, and product performance, and then finally, The only one I've not been able to get a weblog into is IoT. I'm still kind of working on that story. But there's kind of gold in that data, and I'm doing my best not to put on the accent and go for that. But the thing that we've really found out with Splunk is being able to take this kind of big data movement, take data that seemingly you might not have thought as a lot of value, and by able to get access to that rapidly, be able to prototype, test, and work out whether you want to fail fast or continue, you can start to unlock a lot of gold within inside of it. So Splunk, as a company, we're here to make machine data accessible, usable, and valuable to everyone. And the most important part about that is valuable to everyone. Everyone has a different way of consuming data. And a very simplistic example, I'm going through getting a mortgage at the moment. So I'm married, so I sit there and I negotiate with my wife. And I sit there and do all of the financial planning, all that type of stuff, and I go and I basically pitch which mortgage product I think we should go for. And she's obviously the final voice of control. Same piece of data. If I present that to her and I show a bar graph with a lovely trend line showing, don't worry, interest rates are going to flat, profits are going to go up, we're all fine, that was great for me. I work in product management, I see lots of bar charts, I really like those type of things, and I'll sit there and I'll probably trust it. On the other hand, my wife has a maths background, so the first thing she'll say to me is, I want to see every last cell, every last column, every last calculation. And this is where it becomes really important. We have to give the same information to the right person in the right way, otherwise they won't trust that data product. And that's the thing we really focus on Splunk, making it easy to get that information to the right person in the right way. The worst thing you can do is get it to the end person and they don't believe in that data product. You've already lost your core audience, the people that are actually going to use that data. So, gold in the data, this is an example from a banking system. And within inside of some of the data they were looking at, this was just to check whether for IT operations, this is from example UniCredit, you can look up their talk online, they started looking at, was the payment system working? And then someone said, hang on a minute, we know who the merchant ID was, what card type it was it a UniCredit card or not? What did they do? Whereabouts was it? They said, hang on, I can use this now for kind of business analytics and operations, taking these all little pieces of data, enriching them, and giving them context to be able to get some deeper insights into it. So where we really sit is a data platform, but that's not where we really focus. We really focus on kind of very focused use cases, application delivery, IT operations, kind of the core of our business where we started, then security, fraud and compliance, business analytics, and then industrial data and the Internet of Things. And we can deliver that on-premise, in cloud, or both. So you can actually have workloads in the cloud, workloads on-premise, and search both of them at the same time. And we can then use that same data for multiple use cases. But the thing we really focus on is finding out that specific use case and honing in on that, rather than just capturing data for the sake of it. Inside of the platform, we can go from all the way collecting all the way up to that analyze and prediction with vast scalability. So our largest public customer takes in around about 130 terabytes of new data per day into our platform. The nice part about that is the consultant that had to go on site didn't need to write a single custom script. And we feel that as soon as we have to write scripting to make our own product work, we're kind of failing. It should all be through configuration. And that's not our largest customer by far. So lots of customers, but more interestingly, starting to go into the IoT space, so brands like CocaCola, Bosch, and I'm going to go through a few of those. What I'd like to do, though, is do a demo for you. Now, this is going to take some audience participation. So everyone here, I'm going to assume, has some sort of mobile phone. So I'd like you to take your mobile phones out of your pockets and go to splunk.com/shake. When you find that, you'll see a questionnaire. You might guess we're an American company because it's asking what your favorite state is. Pick one of those, and when you press go, what it's doing is it's going to take an event collector. So we're taking your accelerometer data, and as you shake your phone, we're sending that data through AWS, through AWS Lambda, into Splunk in Splunk Cloud, and that's what I'm showing you here. So we can see total amount of shakes. We've got Android, Apple phones. Some people have created team names, so we've got the Splunk German team somewhere in here being very good boys and helping me out. But also see difference between Androids and Apples, shakes by device, and different maps. And this is my favorite type of management map. We've got a map and a pie chart on the same place, so it's very management friendly. So what I'm actually going to show you now is what is this data comprised of? So as we shake, we're actually getting that data coming through in real time. So I go a 30-second window into Splunk. And this is where the beauty of kind of being able to apply a schema on the fly here. So I've got Splunk Germany. So if I just pick on anyone that's got the team name Splunk, and Holger, this is on a 30-second window, so I know when you're giving up with life and stopping shaking. But I can start to see what device we're using. So someone on iOS 9.3, the state they picked, and start to think, well, actually, I want to do something with this data. So I'm just now going to, you can all stop shaking for the moment, just look at the last 15 minutes. I'd really tempted to just say we've got to carry on shaking for the rest of the talk. Okay, so I'm going to just look at this data. And let's just pick on people with iPhones. So I'm using a rare term to search on this. This is the same interface that our customers use when we scale up to vast amounts of data. So I can see the rough pattern over the last 15 minutes. We see one of my colleagues that I asked, please, 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 at least can you shake to make sure this demo doesn't fall flat? Then we get some enthusiasm, and then it eventually starts to wane off. I can now have a look in this iPhone. I've actually got the user agent. So I would quite like to know which iOS version people are on. And I didn't have to think about that up front. So I could write a regular expression, but not everyone in the world can write one. And I'm certainly not going to try doing that live, especially as I'm a product manager. So I used to be technical, but my technical skills are very quickly waning. So I'm going to say I want to take this data, use a regular expression. And I'm going to pick this thing here, and I'm going to call it iOS version. Add that extraction. So now that's going on data that I've already got inside of Splunk. And I can see which iOS versions I have. Oh, we have a bad match. And I could fix that out to say this is not a match, if I remembered how. But let's just, for the moment, just leave that in there. So I can now validate it. Oh, here we go. Say, no, that was wrong. Okay. And I now have just my iOS versions there. And I'm very impressed. We've got someone in the audience. It looks like they had iOS 7.1.2. So what I'm actually doing is I now run this on data across all time. So we're getting a reasonable amount of events. I should have in there a field called iOS. And I can now do something with this. So now let's just look at the top values. I can create a visualization and pick some sort of a thing there. And now I want to save this as a dashboard panel. And what I'm going to do is I'm going to ruin the online demo. This is a shared demo, so I'm going to ruin it for everyone else and save it onto there. So if I now go back to that dashboard, I've gone from raw data, extracting something that now I didn't actually know before I started this demo. I wanted to extract iOS version, and down at the bottom, I have that there. So I can now start to play around with this, maybe add a time range picker to this and do some more things there. So just a very, very simple concept demonstrator of what Splunk is. Now I take that same thing for IoT. I can take a piece of data, we're taking it off your devices with agentless collection, sending it through AWS Lambda to do a little bit of processing on it and into Splunk. Very, very simple, doing that at speed and at scale. I can now decide what do I want to do and what insights do I want to deliver. So we can go back to the slides, please. So some of the capabilities, data ingestion at very, very vast scale, either on-premise or in cloud. Analytics and visualizations, we've also given the ability to plug your own visualizations in. In our latest release, we've made that simple. So they're now packaged as apps. So I can actually download that visualization, maybe develop it myself, and quickly share it with other people. I used to be an on-site consultant. One of the worst things you had to do was create a visualization on not necessarily with Splunk, but any platform. You create the visualization in the development environment, and somehow you've got to get it up to production. Of course, it's always different, so we can now package that and share that across. And then be able to sense, respond, always drill down to that raw data. And the most important part is we have a large partner ecosystem that are working with us to make it easier for you to get data off devices and work with it. So we've got TCP, UDP, all of the standard type of things. Modular input, so Kafka, obviously this type of thing, from message queues. The HTTP event collector that we spoke about now, but also technology partnerships with people like Kepware. So if you've got SCADA data and control systems, we can work with Kepware to get that data off your control system and quickly into Splunk to be able to work with other types of data. The most important thing on top of that, I can now search, alert, visualize, predict, and develop and enrich that data with maybe asset information. So the event collector, we actually now in Docker 1.10 is native. So from Docker, you can actually use a Splunk event collector, start to take all your Docker logs. And we've got people like AWS Lambda, Octablue, AWS IoT, a whole variety of different people that have made it easy if you use those services to get data into Splunk. Oh, and by the way, Splunk Cloud, you can get up and running in a few minutes. There's a free trial sandbox environment for you to use. And then the most important part about this is scalability. Here we work with some phenomenally large organizations who really care about scalability, but don't want the overhead of having to manage complex systems. So then advanced analytics, kind of the current in thing at the moment is machine learning, so making that easy. So on top of that, being able to test, deploy custom machine learning models, the purpose-built visualizations. We've created an app to help guide you through that experience with some sample data and best practices, and then giving you full access to the Python data science library within inside of that. Most important part of this is the model storage, and you can then export that to production. So you can take a sample data set, train your model, and then actually move that trained model over to your production system. So you're not having to do everything on live. So this is my kind of favorite dashboard. We took people on a track day at Splunk. So our chief executive has a couple of very fast cars, took that, put a sensor on the actual car itself, and we can then start to give streaming data from that to be able to understand where people are on the track, where they're fastest. And you might not be able to quite see it, but above the D, you can see it's one of my colleagues who was telling us how great he is at driving. That was him coming off the track and sitting there, and he did it at a nice speed. The interesting thing is, at the end of each lap, we could actually use this to see which corners am I fast, where my G-force is, all of those type of things. Being able to do this again with core products very quickly get to this point, so minimizing the amount of development time I actually need to do. So a few kind of practical examples. VW, if anyone heard of the e-up cars, they did a big event at CeBIT a couple of years ago showing the e-up cars. So we worked with them to be able to, with their connected car program, being able to look at battery life, where the doors open, doors shut, where the car is, and can have an active dashboard. So they built some custom visualizations to be able to show how that goes around the car network. I think there was a talk in here earlier from a car insurer looking at the telematics and now starting to put into cars. So very interesting stuff. The biggest problem with that is bandwidth. So we did a proof of concept for one of these car manufacturers. At the end of the first day, the sales engineer went to them and said, so how big's your data plan? And they're like, well, big enough. And it's like, well, is it kind of a couple of 100 gigabytes a month big enough? And they're like, no. And they realized they'd actually blown their data plan within the first 3 days of the month. So they could go very, very quickly and have a renegotiation with their cell provider to say, can we maybe increase our data plan and minimize that over-plan usage? The interesting thing about that was something that they didn't initially expect when they started the project, just be able to go through data and be able to sit there, and someone taking that tacit knowledge of the business can start to ask and probe and start to get those questions and then operationalize it. The most important part about this is being able to do something with it. So having an alert action framework to integrate with something else. So we actually use this ourselves at Splunk. We kind of eat our own dog food or drink our own champagne, depending on how you want to think about it, and use Splunk to monitor all of our systems, both from our cloud service providers and we have internally. And we're a big kind of Jira and HipChat user. So if anything is a critical alert, we have a custom workflow action that goes out to HipChat. And there's a whole bunch of these available to download prepackaged, or you can build your own. So there's someone at work who's got one of the Philips, the lamps that change color. And he's basically, depending on the amount of times the office beer tap gets used, it starts to change color, whether he has to go and change the taps or not. And then a very large ecosystem. One of the interesting ones, Bayshore, taking SCADA data off IoT devices and allowing that data to then be used for enterprise security. One of the things that's often forgotten around IoT is when you start off, how am I going to secure this type of platform, especially when you get up to big manufacturing, industrial systems, security becomes key. So they can take that information and say what's actually happening at the moment, but then take other control data and plug it in for a security context. So some customer successes. So really, these are around kind of preventive maintenance, working with people like car manufacturers. The biggest barrier for electric cars is battery usage. So how well is that battery performing over time? The holy grail of one of the customers, car customers we're working with is they want to be able to look at what is your average journey. So they know James on a Monday morning drives from this place to that place, and that normally takes 60% of his battery life. On a Sunday, it rains. So what does that mean? That probably means my journey is going to be longer tomorrow. And they're trying to get roadworks in, things like that. So they say, actually, we think it's going to take 63% of battery life to get to work tomorrow. So they can give you an alert the day before to say, your battery's probably not good enough at the moment, you probably want to top it up before you get to work. There are really interesting types of use cases out there. So Zebra Technologies, big manufacturer of kind of devices to allow tracking, printers, all of those type of things. Quite a large organization, 5.6 billion market capitalization, and they tag the NFL players. So it's incredible now. They've got all the people running around. They know exactly what they're doing, heart rates, all of those type of things. The amount of data being generated is phenomenal. But the thing that really matters to them is how do they get the best product to market and make sure that they don't spend a lot of money on devices being sent back, testing, all of those type of things. So the challenge for their printer division was the data wasn't being collected for long-term use, so they couldn't compare historical data. So what was this production run like compared to this one? It wasn't very easily shareable. They didn't really have the skill sets or the technology to be able to consume this data and then move that around. And they didn't have the kind of big plethora of analytics capabilities. So it resulted in, if something went wrong, they had to just kind of all hands on deck. You've all probably been through something like that. And that wasn't really a way of continuing improving their business. So their goal was to find a way of taking all that device information, making it flexible, send that out, and capable of robust kind of analytics, and most importantly, easy to share with someone. The most important part about this is being able to share information to give other people insights into what you're doing and what they're doing. So the solution they went from was take that manufacturing center with all the different service centers and be able to send that data and the test history and the test data into Splunk. So they can actually start to look at different test runs, which allowed faster customer resolution. So when something went wrong, they could look back at this historic test runs, say, have we seen this before on this device? Being able to capture problems earlier in that development cycle, which then means a reduced return rate, which means better improved business decisions, and most importantly, the last figure, reducing the amount of cost it takes to manufacture all of these. So onto kind of other things. I was trying to think, it's an IoT type of talk, so it really has to be planes, trains, and automobiles, but I've managed to get zombies in there as well. So has anyone heard of the CocaCola Freestyle machines? So very popular in the States, but they're basically automated vending machines by Coca-Cola. Not very glamorous, wouldn't have thought there's a lot of business value of the data from it. But they actually sat there and went, we want to first make sure these devices are working. So you can go there and you say, I want a Diet Coke, and it's got probably 8 or different flavors, vanilla, orange, something like that, weird and wonderful combinations. So before, they had to take that data, save it on the device. Every few hours, they would FTP it online. They would then have to process that data and then ingest it to try and work out what's happening. So they changed that, and using just the same technology as you're using for the shake demo, as soon as someone vends, or they interact with the machine, it's sending data straight away through AWS into Splunk Cloud. So they can actually look at, is the machine working? Is there a problem with the machine? So they can start to get an engineer out as fast as possible in case if a machine's showing signs of degrading. The most interesting part about it was insights into customer interactions. The Coca-Cola kind of advertising team and marketing team said, does that mean we actually get to understand who are buying what different things there? So every time you click, we know someone's making that purchase decision. The other thing that Coke will do is they now have an app with a QR reader, so I can say, I want my favorite Coke, I can show it the QR code on my app, and it will immediately vend. So Coke now also know for those people, James has gone to this particular machine and bought this style Coke. I'm not sure the value of this insights, but they found on one of the big college campuses in the US that more people buy full-fat Coke just before should say Waking Dead. I thought I'd change that. Walking Dead comes on. I'm not sure of the complete brand value behind that, but the type of the insights they'll be able to understand. So they can take that to their marketing team and say, could you actually run a more specific ad campaign or something like that? Do we want to go and buy ad slot for these type of programs? They're quite interesting coming out of just pressing a button on a machine. Gatwick Airport. So Gatwick Airport see themselves really as a shopping centre. And they said, we have one of the best shopping centre setups in the world as an airport. I have guaranteed to have people come in. I know how many people are going to be coming through my shopping centre every day, and I pretty much know that in advance. I know they'll stay there for anything from about an hour, hour and a half, up to about 3 hours, and then I'm pretty much guaranteed they'll leave. So I don't have people hanging around not doing anything. So the two things they want to do, they want to make sure that plane turnaround time is working, because that's one of the most valuable things. But as a business, Gatwick Airport now competes with other airports around London. So they want to give you the best experience they can. So they were using Splunk Cloud to take the data off all of those end devices. So from the landing, the radar, even the airport, the bridge that comes and kind of goes onto the plane, and sometimes you get that annoying message with say, very sorry, the air bridge doesn't work, you're going to have to go down steps and onto a bus. So they can start to monitor all of those type of things. Flight turnaround, board scans, when you go through and scan your pass, X-ray, passenger flow, all of those type of things. They then took it one step further and starting to look into the motorway in advance. So they have traffic cameras going down, I can't remember, it's either the M23 or the M26, and it says whether I'm getting a queue of traffic building up in advance. And if there's a queue of traffic, I know there are going to be people arriving all in one go as the blockage gets free, desperate to check in as fast as possible. So they can take a proactive approach and redeploy their staff, maybe put them on a break, so when the sudden rush hits, they have all the check-ins open. The most interesting thing about this is all of this data originally was just considered manufacturing data, IoT type of stuff. We just want to check it's working. They said, hang on a minute, this actually gives us insights into our business and how we run it. And so their concept now is we don't have a IoT operations center. They see themselves as more of a business operations center. And to give you an example of how long it took them, they had Splunk Cloud up and running pretty much instantly. Then about 2 weeks to get the data negotiation signed off to be able to send data to Splunk Cloud. And within 4 weeks, they had their first set of live operational dashboards up and running, including the CEO had just bought an Apple Watch and so had to justify its existence and has an alert when he gets critical incidents in the airport. He now gets it on his watch. To give you some examples of the dashboards, here's looking at the airfield's turnaround time. So they've kind of obfuscated some of the company names in there, but you're looking at percentage turnaround time, the accuracy of the air bridge, and a whole bunch of different things there. So they're actually starting to look at the airport as a living, breathing system. Another one is looking at heat maps of the two different terminals and where we're getting security queues, check-in queues, all of those type of things, so they can start to capacity planning to redeploy staff. They're looking at what are the pinch points that really make you unhappy. One of the most bizarre things that they do is they take the data from the restrooms. So how many times does a toilet get flushed? think about when you go to an airport, when you're most unhappiest, when there's a big queue and you want to go to the toilet and half of them are out of order. And you see that the person's got another 20 minutes on their hourly route to come round and check that again. So they can actually look at that and say, either the toilet's not working, it's been, the throughput through it's been so high, redeploy that staff, have happier customers who are then more likely to maybe spend some money and maybe return back, so give a better experience. So really thinking about how could these little bits of toilet flushes give a customer, and we can use that to make a better experience. So some slightly abstract thinking from the airport there. So train sense data. Have you ever seen the big American trains? So these are almost a kind of almost half-mile, mile-long trains. The biggest problem they have is kind of the slinky effect. They have a few feet of give between them, so as they move up and down, accelerate, the whole trains kind of move in and out. They're so heavy that when you go over a hill, when half the train has gone over that hill, they can just take their foot off the accelerator and let the rest of the train pull itself over. So they take all of the data from the sensors. They worked with one of our advanced analytics partners who spent a lot of time building machine learning models for them. And they reckon they've saved themselves over $1 billion for themselves and their customers in fuel usage. I think our marketing department wanted to do an ROI calculation on this. It's actually a tiny amount of data. We kind of sat there and went, we can't really say millions upon millions and millions of ROI because not many people would believe you. But a really interesting use case. And again, partnering, doing machine learning, predictive analytics to give the drivers insights into how they're behaving. All again from really small, tiny bits of data. Deutsche Bahn, Holger, if he's here in the audience, was part of the team that did a hackathon. So it was quite interesting. Being a kind of more startup culture here, we turned up with a MacBook. We had one of another company turned up with an entire rack of hardware. 24 hours later, we were told we were the winners of the hackathon, which you can just imagine the kind of the smug feeling that, with a MacBook, you can do quite a lot there. But it's really interesting, we're looking at transport infrastructure and how we could help Deutsche Bahn get ideas on where to look at improving their infrastructure. Improving their infrastructure means trains run on time, which means happier customers. So taking that data, looking at the seemingly messy, kind of ugly data, extracting kind of the key key value pairs out of it, starting to put it into what are the top 10 notifications about issues around the infrastructure, looking at that problem over time. The only thing I don't like about the slides is its pie chart. I have a fundamental problem with pie charts. I don't know if anyone else shares my hatred of pie charts in this audience, but it's the one visualization I'd like to drop from Splunk, but their managers wouldn't be happy. The other type of thing, looking at, well, what is the problem with concrete and wood on different types of areas? So we're actually looking at when I get sleepers having problems on certain routes, or I'm actually better to have wooden sleepers or concrete sleepers. Now, most of the staff that are deploying this have their experience to say which one it should be, but what we're giving them is some evidence and some data to support their tacit knowledge to try and give them even more insights into those routes. And then finally, looking at problems and delays within in routes. So just adding a Sankey graph, so we can see the kind of the biggest problem of area. The wider it is, we have, I think it's a route towards Frankfurt, which had a huge track deviations. So again, all of this done in less than 24 hours. And the one I really like is in Thailand. Looking at crops and being able to warn against floods to do flood preventions. So it's a very, very small system that monitors water levels, goes through Splunk, tiny amounts of data, and then we'll start to send SMSs out to the farmers to be able to give them up-to-date information on water levels and if there are problems in the areas around them. So kind of a really nice story there about just taking small amounts of data but having a real impact in people being able to understand what's going on in their surrounding area. Biggest kind of automation. So Target, huge US store, very similar to Amazon. The same type of things happening in hospitals where I'm actually doing automated stock refresh. So actually most hospitals now have a robot that will actually stock the drugs and then dispense them to the pharmacist who then finally gives them over. So they're taking all of that data from the robots to look at pattern reporting, failure detections, and most important part about it, preventive maintenance, to be able to reduce the amount of data coming through. The thing that Target really said to us was they wanted to spend time on understanding their robots, not playing with technology. They wanted to actually get the fastest time to value possible. And I like this so much, I've clearly put this in twice. About saving $1 billion with New York Airbrake. And then kind of one of my last slides, just because of the sheer scale of it, energy readings. So McKinney's, a big integrator in the US, worked with the US Air Force Base. The US Air Force Base Elgin is one of the biggest bases in the world. 728 acres of Air Force Base. So hundreds of buildings, tens of thousands of personnel on the Air Force Base. And one of their biggest costs, energy, because they need to have the lights on, heating, all of those type of things. So they took all of the sensors throughout the entire infrastructure and started putting that through Splunk. And they ended up putting a custom user experience on top of the Splunk engine to be able to show them which buildings are being used, which buildings aren't being used. The interesting things are, if air conditioning starts kicking in, it is a good indication. If it's kicking in at a faster rate than other rooms adjacent to it, it's a good indication that room is being used and there are people inside of it. They can even guesstimate the amount of people inside of that room. So are we using the most appropriate room? And where do I want to redeploy buildings, uses, all those functions? So a really interesting type of use case there. And again, I think they're saving themselves about $2.4 million per year by able to take all of that information, add it to their business knowledge about their own business with McKinney's, and be able to get further insights to it. I did say one last one, but Comcast. They take in 100 terabytes, their X1 platform. And one of the most interesting things about this is we all work in IT. So we've all probably done family support for someone's laptop or someone's router. So you get the phone call, the internet's broken. And at which point you can't help yourself saying, well, the internet's not really broken, it's our router that's broken, and have the ensuing argument. But what's the first thing you do? You turn it off, and you turn it back on again. If it then doesn't work, you're kind of stuck. But that solves so many of IT problems. Where last customer I worked at, they had a poster saying, please reboot your computer. Last year, when the service desk asked people to do that, that solved 75% of all problems. So Comcast took the same approach. So every time you browse something, purchase something, click something on the X1 platform, it goes through Splunk. They also are having a look at the behavior of the box. Is the box working? Is it being slow to respond to certain commands? If it's slow, they use a bit of predictive analytics to say, is this box looking like it's about to crash? If it is, and no one's streaming media, let's send it a reboot command. So next time you actually come to use that box, it is always on. Just simple little things. Getting the right data to the right platform with the right insight allows a much more positive customer experience, which means someone doesn't phone a call center. Every time someone phones a call center, it costs them $8. Now, $8 doesn't sound very much until you are in the United States with millions of customers and you start to get bigger outages, you get a huge amount of cost there. So being able to do everything to minimize that by understanding that behavior. So really what we're working at is being able to take kind of cloud workloads, those enterprise workloads, IoT workloads, merging them all together into these concepts of operations centers. I really started my career in IT operations, and it took me a while to realize that the most important thing about IT operations is it captures pretty much every single piece of flowing business data through your enterprise that can be repurposed. So taking that and being able to give that to the right person in the right context can add a tremendous amount of value to your organization. So thank you very much. Do we have any questions? Well, enjoy the rest of your conference. If you were shy and wanted to ask me a question one-on-one, I'll just hang around at the back for a few moments. Thank you very much.